Well, good afternoon, and welcome everyone to today's Southern Fire Exchange webinar. My name is David Godwin, and I am the Outreach Coordinator for the Southern Fire Exchange. Today, we're excited to have our guest speaker, Angie Enyedi, lead forecaster with the Jacksonville, Florida National Weather Service office. Today, Angie will be giving a presentation discussing National Weather Service fire weather forecast products produced for the Southern U.S. Angie is a lead forecaster at the National Weather Service office in Jacksonville, Florida. She's been with the National Weather Service for 15 years, 13 of them in Jacksonville. Angie recently became the fire weather program leader at NWS Jax and has truly enjoyed working with various state, federal, and private land management agencies as she learns more about wildland fire. She has almost completed her Type 1 Incident Meteorologist taskbook, and she only needs 6 more days to wrap things up. So welcome, Angie. We're excited to have you here with us today. In just one moment as we switch over our slideshows and you can take things away.
Okay, thanks, David. All right, everyone. My name's Angie Enyedi. Last name rhymes with spaghetti. So across most of our area, I'm known as Angie Spaghetti. So Angie's just fine. And as David said, I am one of your friendly National Weather Service meteorologists. Again, most of you probably already know this, but the National Weather Service meteorologists are the behind-the-scenes folks. We're not televised. And our main mission is to issue life-saving and property-protecting watches and warnings. Let me go ahead and start transitioning here to my screen. If it will take here. David, do you see the opening slide?
Yes, I do.
Okay. All right, so we are going to rock and roll here. Now, as David said, I'm going to mainly focus on what I know, which is Florida weather and fire weather. And as David alluded to, I am relatively new in the more intimate world of getting to know directly our fire partners, our fire customers, like you guys and girls who are on the telecon. I've been a fire weather forecaster for 15 years. But actually getting out in the field and getting the ability to interact with everybody has just been over the past year or so. And also I'm on my quest to become a Type 1 incident meteorologist. I had the awesome experience of being dispatched last year as a trainee to the Shawakam Fire Complex, which was in the Eastern Cascades. And got to work with the Pacific Northwest Type Team 2 and interact with a lot of the ground crews and teammates out there. So it was a great experience, and I look forward to hopefully getting dispatched again this year. It's starting looking a little toasty out there, out in the west. And actually, one of my friends, one of the incident meteorologists from the Melbourne office, got dispatched 2 days ago to work a fire in the Everglades. So we are starting to light up in some of our areas out here in the east as well. So with that, I will go ahead and delve into the presentation. It will take us about 30 to maybe 40 minutes. And as David said, we'll have plenty of time at the end for questions and interactions. And let's get right into it. So let me advance to the next one. So our outline for this presentation, we're going to talk about the National Weather Service and the various products and support services that we have to offer to our fire weather customers. The second part of the presentation will talk about our fire weather forecast interface and how we actually, I'll give you some screenshots of our interface that we use here in our office to actually prepare the fire weather forecast. And then we'll break down the elements of the fire weather forecast and define each of the indices. And finally, at the end, we'll start talking about dispersion indices. And these are varied all across the country of what will actually appear in the National Weather Service fire weather forecast. Out west, they use the Haynes Index, whereas in Florida, we use something called the LabDisc Dispersion Index. And there's some pros and cons with every stability index out there. And we'll delve into a little bit more of the details later on in the presentation. So, the National Weather Service, the agency that I work for, we are a federal agency. We're part of the Department of Commerce. And no matter where you go in the continental United States, even out towards Hawaii and Guam, there's a Weather Service office staffed with at least 2 meteorologists 24/7. And those meteorologists are also fire weather forecasters. They've had the experience of working the fire weather desk and preparing forecasts. And we're all trained at giving phone briefings. So any time of day, you guys or girls need a weather briefing, whether you're responding to a large incident or a small incident, feel free to call us. And you need to look up who your local weather service contact number, and you can do so through the main weather service website. It's weather.gov, and I will navigate a little bit later on in the presentation to how you can actually look up your local weather service office and which one serves your area. But we are there to support you, your mission, and number one, your safety and your crew's safety. So with that being said, we also, as I said before, we specialize. One of our program areas is fire weather forecasting. And when I talk about a local fire weather forecast program from each office, we're talking about fire weather forecasts, the red flag watch and warning products. Those come from the National Weather Service office. We also issue spot forecasts, which are latitude, longitude specific forecasts for a burn site. And then we also have the Incident Meteorologist program, which is the program that I'm being trained up for right now. So here's a little refined picture here of the fire weather program leaders that serve Florida. Now, no matter where you are in the United States, each weather service office has a designated fire weather program leader. And all the leaders are meteorologists, but they have a special affinity or liking for, if you will, the fire weather customers. So as David mentioned, I'm the contact for Northeast Florida, for the Northeast Florida counties there. And again, you can look up your local contact information through the different weather service websites, and I will navigate you through that here in a few slides. So here's a screenshot of what our local National Weather Service Jacksonville homepage looks like. And through these weather service web pages, these should be, hopefully one of your one-stop shops when you're doing your morning weather briefings or want to get a feel for what the upcoming weekly forecast is like, so you get a feel for burning conditions. And a lot of the weather service offices, there's two different interfaces right now. The one I'm showing you is still active across the southern region of the United States. So these are what the southern region offices are displaying. So when you log on, you're going to see these pictures. We call them graphicasts. If we have dangerous fire weather conditions out there, we'll actually have a graphicast. It's just kind of a large overview of the forecast weather or weather headlines that are going on across that specific area's office's area of responsibility. There is a link. It's kind of hard to see, but over on the left side there's an option that's labeled Fire Weather, and if you click on that interface, you will be taken to the local office's Fire Weather webpage. And all of these are different. The one that I just displayed is a snippet of the National Weather Service Jacksonville's Fire Weather webpage. All of the Weather Service Fire Weather web pages will have three main things. You'll always have a link to the latest fire weather forecast. You'll have a link to the spot forecast interface if you want to request a spot forecast, and we'll talk about what that is in a little bit. And also there should always be a link to the latest state operating plan. Now for our area, we service two states, Florida and portions of Southeast Georgia, so we have on our webpage links to the Florida and Georgia state operating plans. But those are the three main things that you should always find on all weather service fire weather web pages. And then depending on the customer's needs, the fire weather program leader for each office, weather service office, may add additional links. So this website was created based on collaboration with our local partners in Northeast Florida and Southeast Georgia. The weather service offices and the meteorologists there can also be a great resource if you want to come for a station tour, you want to actually get a feel for, who the meteorologists are, see the people behind the scenes that you're requesting the spots from. Just to establish that face-to-face connection is really important. So we're all open to that, not just us here in the Jacksonville office. All the weather service offices crave for that one-on-one interaction with our fire weather customers. So again, please make that contact with your local weather service office if you haven't already done so. So also on all the Weather Service web pages, there is a smaller graphic, not as pretty looking, if you will, and that is the graphic in the middle where the red arrow is pointing. We call this our point and click interface. And basically what this is a way for you to extract a site-specific latitude and longitude forecast off of our gridded database. And I'm throwing out a lot of gridded terms, and I'll show you what that means later, but the way we prepare our forecast is actually across a grid. We ingest model data across the grid space and work our meteorological magic on the forecast grids. We publish the grids, and the grids enable our users, like you all, to extract a site-specific forecast. So by clicking on this point-and-click interface, you're able to extract things that are very much like a spot forecast. The graphic that you see that's outlined in the red is something we call a meteogram. It's basically a big word for a weather trend chart forecast, if you will. And you can look at this either graphically or you can just have raw numbers. So it's showing you, as you go out through time, hourly forecast trends. It's giving you an idea of what the forecast temperature is, what the forecast dew point, what the wind trends are going to be, what the RH is going to be, rain chances, thunderstorm chances. And we have this available out through 7 days. Are we going to be right out through 7 days? Heck no. We're going to at least have a sense of what the trends are going to be, which can help you in your planning process. In the short term or in the near term forecast, when I would say out to 36 hours or so, we should be pretty darn close to what the latest model guidance is suggesting and what we're feeling will really evolve. So this can really help not only after you extract your spot forecast, but it can help you give a sense of, okay, well, you know, through the course of the day, has the forecast changed at all? And it can be reflected through these meteograms. So it's a little convoluted, well, not too much so, the way you extract these. And again, I'll walk you through that here in a couple slides. So also what the Weather Service does is we support the Incident Meteorologist program. That's what the IMET stands for there. That's a picture of me there on my first big fire last year out in the Cascades. It was an awesome experience. We also like to work with our fire weather customers on getting our meteorologists, the ones that are preparing the fire weather forecast, out in the field to what we call FAM fires or familiarization fires. Again, so we can establish that you know, that one-on-one contact with each other, and so you learn from us, we can learn what your needs are to better serve you. So we're all very much about customer support and building a tight rapport with each other. Okay, so now we're going to talk about the main fire weather forecast products that the National Weather Service issues, and each office issues these products. The first one we're going to talk about is what we call the Fire Weather Planning Forecast. We call it the FWF for short. And these forecasts are issued at least once a day by all the Weather Service offices. Here in Florida, we issue them twice a day, one in the early morning and then one in the late afternoon. And the thing to note about these planning forecasts is that these are for large zones. And in this particular snippet of the fire weather planning forecast for our area, okay, so we were talking about the National Weather Service fire weather planning forecasts and how these forecasts are for a large area. In our neck of the woods, we basically use counties or sections of counties from inland to coastal. Out west, I think they've done some of their fire weather forecast zones based on pre-existing fire zones, working with their customers. So anyway, the thing to remember is that these are large area averages. Okay, so they're not going to necessarily be quite representative of your local burn site. For us, you know, we have all kinds of deeply cut estuary systems in our area, and the winds and the humidity can vary greatly if you're close to a body of water. If you're farther inland versus closer to the coast, the winds could be significant. Out west, where there's more mountainous terrain, these county or zone averages won't take into effect topography very well. So is your fire at the higher elevation, or is it down in a valley? So we just want you guys to keep in mind what this forecast product is showing you. It's a large area average. Now, to request a more site-specific forecast, that's where you can utilize the spot forecast interface that's available from all the National Weather Service web pages, from the Fire Weather web page interface. And the snippet of the spot that you see here, this is a latitude longitude specific forecast. And again, these numbers are being extracted from the same gridded interface that the National Weather Service meteorologists use to prepare the larger scale fire weather planning forecast, that product that's in the background there. But this spot forecast is going to have a resolution as high as 2.5 kilometers. That's the best resolution that we have in our gridded database right now. But hopefully when you submit your request for a spot forecast, you're giving the meteorologist on the other end some near real-time weather data, like you're slinging or using a Kestrel or a little weather station to extract a temperature, an RH forecast, and wind information. And that way the meteorologist on the receiving end of your spot forecast can kind of baseline their gridded forecast on your observation. So say, for example, our gridded forecast has temperatures around 70, but you're out there and you just took a recent weather ob near your burn site and you've got temperatures that are 75. Well, we know we need to kind of increase temperatures in this site-specific zone or spot forecast to more reflect the conditions near your burn site. So the spot forecast is the place where you're going to get a much more refined forecast for a specific burn site. Another product that we issue, we call it the FWM. It stands for the Fire Weather Matrix. And basically, this is a product that's issued towards the end of the day, and they're forecast weather parameters for the next period. So this afternoon we'll issue our FWM product around 3 o'clock. And basically this product is coded and it has information like RHs, winds, rain chances, amount of wetting rain in the forecast. And this is all input that goes into the WIMS forecast models, weather forecast models. So that's kind of a behind the scenes product that we issue. So the more visible Weather Service fire support products are the spot forecast and the fire weather planning forecast. Okay, the Weather Service, as I said, our main mission is to issue watches and warnings for the protection of life and property. In the severe weather world, that's tornado watches and warnings, severe weather watches and warnings, hurricane watches and warnings. In the fire weather world, those products are in the form of what we call the Fire Weather Watch, which is issued within about 24 to 72 hours of critical fire weather conditions. And these conditions, quote-unquote conditions, vary across the country. For example, one of our criteria for critical fire, for fire danger in our area is having relative humidities falling below 28%. Now, folks out west in California, they'd be jumping up and down, going crazy, happy that their RH has climbed up to 28%. But for us here in the great southeast, that's a low humidity for us. So the actual criteria by which these fire weather watches and red flag warnings are issued, it varies across the country. So it's important to know what your local area's thresholds are for which trigger these fire weather watches and warnings to be issued. And again, you can find all that information in your annual operating plan that's specific for your area. So fire weather watches are like our heads-up product, and in our office and many offices across the Weather Service, we issue these graphics. We call them Graphicast. This is an example of one that we put out for a fire weather watch I think it was last fall. And we actually put these on our home page. We send them out through social media. That's one thing to keep in mind, that all Weather Service offices are active on Twitter and Facebook now. And we also, in our office, issue partner emails. So we have a fire weather partner email list that we will do a mass mail out, blind carbon copy everybody on the email list, just to give them a heads up. Hey, look, we're expecting near critical fire weather conditions within a day or two. So heads up kind of deal. Now the red flag warning, this is when we are expecting imminent red flag conditions, usually within the 12 to 24 hour time period. And red flag warning event occurs when critical fire weather conditions can lead to extensive fire weather growth. And just for grins, I put in the criteria for Northeast Florida. These are the criteria for which we will issue a red flag warning in our area if we have 4 consecutive hours of RH less than 28%. and ERC, which is basically kind of a measure of fuel moisture. It stands for energy release component of greater than 37. Or the other condition is we have RH less than 28, 20-foot winds greater than or equal to 15 miles an hour, and ERC is greater than or equal to 26 units. And again, there's an example of one of our red flag warning graphicasts that we would put out and distribute via email to our fire weather partners on our fire weather email list. Okay, so now what I'd like to do is take a little break and from the PowerPoint, and I am going to navigate you guys and girls through the main Weather Service website and how to get to your local Weather Service office and how to extract that point-and-click forecast, that latitude, longitude specific forecast. So the main Weather Service website, the kind of the main portal, if you will, is weather.gov. So I'm going to click on that, and over in another window, my main website loaded, so let me drag it over here. Okay, so this is the main portal for all the weather information you could ever want and need. And this is an interactive map. So what I'm going to do is I'm going to click on Northeast Florida, Southeast Georgia, and you can click anywhere in the country and you will be taken to that local area's Weather Service webpage. So this is an image that just loaded of our current web page. Here across the top are those graphicasts that I was talking about earlier. Now I'm going to scroll down a little bit, and over on the left-hand menu underneath forecast there's a fire weather link. I'm going to click on that. This is what our main fire weather web page looks like for Northeast Florida, Southeast Georgia, and again the interface is going to be a little bit different. I know for Florida offices, Weather Service offices, we are working to try to streamline our web page, but even on our web pages to make it a little bit more consistent. But I've even heard through the grapevine that all Weather Service offices are going to try to be streamlining their fire weather web page interface for across the country. So hopefully it'll be even more easy in the future for folks to navigate as they travel across country to get to their beloved fire weather products from the National Weather Service. So I'm going to go back to the main web page now, and now I'm going to scroll down to this interactive map. This is the point-and-click interface. This is where you can extract a forecast that's almost like a spot forecast for your specific area. So I'm going to click on one of the areas that I'm quite familiar with, the Jennings State Forest, which is in Clay County, Florida. And the page that loads, this is a latitude, longitude specific forecast page. If there are any current Weather Service watches or warnings in effect, it's going to be headlined up here under the Hazardous Weather Conditions tab. If you scroll down even farther, there's a 7-day forecast for the site that you clicked on. Keep scrolling down. There is an Esri map over here that you can drag and use to click on. Say you want to go closer to where your burn site might be. So say we're burning up here in the Jennings State Forest, kind of on the northwest sector of the area. You can click even further to try to get a better detail, but keep in mind the products that load are only going to be, the highest resolution is going to be to 2.5 kilometers. That's as best as our grid space can do. So I'm going to click on that. A new page loads, even more refined for the area that I'm going to burn. So we get a generic 7-day forecast for that specific location. Keep scrolling down, and towards the very bottom of the page you're going to see this thing called the hourly weather graph. You can click on that, and the page that loads is going to be hourly weather trends for that specific site out through 7 days. And this is pulling directly from the same gridded interface that your fire weather planning forecast was pulled from. It's going to be pulling from the same interface that initially your forecasters use to create your spot forecast. Then they'll manually go in and kind of baseline the numbers based on input that you give them if you give them weather near your burn site. But this is all coming from the same database. So there will be overall consistency between the products, but keep in mind from that fire weather planning forecast, that's a huge aerial average, whereas the forecast that you're seeing right in front of you, this hourly meteogram or weather trend forecast, is for a specific latitude longitude point. You guys see that there in the upper upper, I was going to say northwest part of the web page, in the top left of the web page there. And so you can scroll down, you can add mixing heights, transport winds, dispersion index. I know in Florida we're working to try to add I think we're going to add the LAVORI, which is low visibility occurrence risk index, and I'll talk about what that is a little bit later. So basically you can use this as a planning tool. You can use it to monitor how your spot is doing compared to you know, a more kind of a larger scale forecast. So this is a great tool. A lot of our customers here in Northeast Florida, Southeast Georgia have really been drawn to using these hourly trends for planning purposes. This forecast interface is updated with a big overhaul twice a day with each forecast package. But many offices, like our office here in Jacksonville, we actually keep these grids updated hourly. So we monitor how radars evolve. We monitor how the sea breeze is pushing inland. And if our forecast in the short term becomes unrepresentative, then we go through and we update our forecast accordingly. So this is one really great resource. If you don't like all the lines everywhere, the spaghetti lines, you can scroll to the bottom and you can request the, I think it's the tabular forecast here. And basically you get all the same data, but it's in numbers. And what a lot of our burners like to do here is they'll just kind of block off the chunk of time in the forecast. Say they're going to burn from, well, probably not 18Z, but say you know, they got a burn starting at 10 o'clock and they're going to burn till 5. They'll just kind of draw a couple of vertical lines between that chunk of time and keep that in their back pocket. So this is a great tool that if you're not aware of can hopefully really help you out. Okay, let me go back to my presentation. I want to make sure I covered. Okay, so those were the main things I wanted to show you that you can extract from the Weather Service websites. And if desired, I actually have a little worksheet to kind of navigate folks through that I take to my fire weather talks on how to extract those meteograms. And I can push that to David, and I'm sure there's a way he can send it out to you guys and girls if you're interested in it. So it's a little cumbersome, but the data is there, and we want to make sure folks know how to get it. It's there for you. Okay, so now we're going to step through another chapter of our presentation, and I'm going to kind of generically walk you through how we, on our end, the National Weather Service meteorologists, prepare our fire weather forecasts. So what you're seeing is a snippet of our forecast interface. It's called the Graphical Forecast Editor. It's called GFE. Again, we're NOAA, the National Organization for the Advancement of Acronyms, so everything has an acronym with it. So in this GFE, this Graphical Forecast Editor interface, what I have over on the left side is a list of weather parameters. So the top line where it says T surface forecasts, those are hourly temperature forecasts. The next line down is TD, that's hourly dew points. The next line down is relative humidity, RH. Then I have my minimum RH grid and my maximum RH grid. Farther down I have mixing heights. Then I have surface winds, transport winds. Then the next tier are ceiling heights. Then the LAVORI, which is low visibility occurrence risk index, and we'll talk about that, what that is in a minute. And then LDSI, that's the Labdus dispersion index, which we use as our stability term here in Northeast Florida. And then at the very bottom of this grid is LAL, that's lightning activity level. And so the way we prepare our forecast on our end is we look at model data and we compare which models are doing well, which ones are showing trends, which ones handle the winds better, which ones are doing a good job with the temperatures. And we can use a blend, if we want to, of all these different models, and we ingest that model data into these hourly or 3-hourly grids. And we can blend the models together because no one model is going to actually nail all areas. And we can apply different grid editing techniques, like many times I'll increase the wind speeds along the coast and along our rivers in our edit area. So hopefully what you guys are seeing there on the right side of the image, that's actually a picture of North Florida and South Georgia, and then that gray outline are the counties. So I didn't really explain that very well. And the particular image that you're seeing there is at the time I took this picture, this is a minimum relative humidity forecast for Sunday, December 14th. And so we go in there and we blend in the model data, we do our little local knowledge tweaks and adjustments. And so what we get is a forecast out through 7 days for many of these different parameters over a grid space. And again, this is a 2.5 kilometer resolution interface. So we prepare basically a gridded forecast. So again, this is just going to go through and kind of show you our hourly temps and dew points. These are our RHs and max and min RHs, our hourly winds and transport winds, our mixing heights, our dispersion. So out of that gridded forecast falls out the word forecast. So this is an example again of that fire weather forecast product that we see. The planning forecast. This is that aerial average again for one of our counties in North Florida, Columbia County. So all of the forecasts that you get from the National Weather Service fall out of that gridded forecast product. There's also other products that you can use that are available. We have graphics that you can use. Maybe they can be of help in getting an overall picture. There are still some collaboration goals that we're trying to meet between different National Weather Service offices. In some of the grid products, you can actually see boundaries between where one Weather Service area begins and the other one ends. So we're constantly working to try to provide a more seamless transition between all these different weather elements in our gridded graphic products. But again, these are all tools that are available for you guys and girls to use. So now what we're going to do is we're going to break down the different elements in the fire weather planning forecast, and I'm going to mainly focus on the ones that we do here in Florida. The fire weather planning forecast will vary across the country, and the reason for that is it's a collaborative product. The Weather Service offices work with our land management agencies in trying to refine what actual parameters do they want to see in here. Like, for example, we have the Labdis Dispersion Index. Well, out west, they have the Haynes Index. And so instead of the Dispersion Index, it will be the Haynes in the fire weather forecast out in the western region. They have upslope and downslope winds separated in their fire weather planning forecast out in the west. So again, I'll be focusing specifically on our products here in Florida and South Georgia. So just keep in mind that this product can take on, it'll be relatively the same format, but different parameters will be embedded within it. So again, if you want to see what parameters will be embedded within your specific fire weather planning forecast, you need to reference that product called the Annual Operating Plan. And that's available through all the Weather Service fire weather websites. So operational periods, they're 12-hour chunks of time that we forecast for in this big area average forecast. And for Florida and South Georgia offices, we go from 6 a.m. to 6 p.m. for an operational period. And so forecast parameters, we're going to kind of break down the top portion. We forecast prevailing cloud cover. That's an average of the prevailing sky condition over that 12-hour period. The maximum rain chance within that entire zone for the 12-hour forecast period and the dominant weather type. Max-min temperatures, and that's an average of max-min temperatures across that whole forecast zone. Max-min humidity across that forecast zone, and again, that's an average. And then also the LAL, the lightning activity level, and that's forecast dependent on the coverage of thunderstorms that we advertise. Is it going to be isolated thunderstorms? Well, then the LAL is going to be relatively low. Is it numerous to widespread thunderstorms? Then the LAL, that's going to be a higher number. Okay, so now we're going to look at the other tier of parameters that are forecast in the fire weather forecast, and this is kind of the bottom part of the table. One of the parameters is mixing height. What is mixing height? The mixing height is the height above ground level in feet above ground level at which stability is sufficient enough to inhibit warm air to continue to rise, to inhibit vertical motion. So this is kind of like a lid or the cap on the atmosphere. So in this particular graphic here, it's basically the height of the cumulus clouds. So they're all a similar height right there. So in this particular image, the mixing height is usually the height of a low-level inversion. The transport wind also appears in the forecast product, and the transport wind is an average wind vector from the surface all the way up to the height of the mixing height. So for the Weather Service first we forecast the mixing height, and we use different tools to do that. We usually relate the mixing height to the height of, it relates to the forecast high temperature of the day, how much moisture is present in the air, and once we forecast our mixing height, then we will extract the transport winds. So again, that's the average wind vector from the surface up to the height of the mixing height. The other parameters towards the bottom of the fire weather planning forecast are the stability index and the dispersion index, which basically equates to a measure of stability. And these indices can vary all across the country. In Florida, we use the Labdus Dispersion Index. And this particular index takes into account many of our forecast fire weather parameters, including wind speed, mixing height, transport winds, prevailing cloud cover, and ceiling height. What's the height of the lowest base of the clouds? So this is a very comprehensive index, and we'll break down this Labdus Dispersion Index here in a minute. And then finally, the last element of the planning forecast here at the bottom is what we call the LVORI, and this is stands for the Low Visibility Occurrence Risk Index. And this was a collaborative index that was requested by the Florida Highway Patrol after a lot of horrible fatal accidents where smoke interacted with fog on the interstates in our area. So they had requested some sort of scale that they could reference in the fire weather forecast to see if fog and smoke settling down to the ground is going to be a concern at night. So basically the input that goes into this LVORI parameter are forecast relative humidities and the nighttime dispersion. That's what DI stands for. So when you have high humidity at night and low dispersions, then that equates to a higher LVORI index, which means that there's a low visibility potential. And the thing that we're trying to caution folks on, the Highway Patrol, is that during the warm season, this LVORI at night, at least here in Florida, is always high. It's almost always an 8, 9, or 10. So the maximum is a 10 on this LVORI scale. I mean, we're always super moist and saturated at nighttime here in Florida, and most of the time we decouple or the winds relax and we have low dispersions at nighttime. So this parameter can be misleading. It's pretty good during the cool season, from the mid-fall to the early spring, to help forecast the potential of fog, and if there's a burn in the area, the smoke settling down to the ground. But it can be misleading, especially during the warm season, and that's something that we're working to educate our partners on. Okay, so now what we're going to do is we're going to talk about different stability indices, and we'll go into a little bit more detail on this number 4, the Labdus Dispersion Index. That's the one that we use here in Florida. And we'll talk about why we use it and also why we're looking into maybe pursuing a different type of index. And that's where we're hoping we can work with the Southern Fire Exchange perhaps to help us try to find another index, because it has its pros, but it does have its cons, and we'll talk about that. So basically what these different indices are, they measure stability. And what is atmospheric stability? Well, it's basically using the lapse rate. And what is this thing called lapse rate? Well, lapse rate is the temperature change in a layer of the atmosphere. And meteorologists use lapse rate all the time to determine the natural ability of the air to want to rise. You have to have air that's rising, cooling, condensing to form clouds, and you have to have clouds before you even have severe weather. So we look at lapse rate all the time. Lapse rate, and basically the stability index, can help us give a sense of how vigorous that warm air over a fire site wants to rise. Is it going to become very unstable? And an unstable atmosphere can fuel fire growth. It can lead to explosive fire growth. Okay, so now we're going to talk about each one of these indices individually. So this first index is the Davis Stability Index, and this particular index looks at the temperature lapse rate in the lowest 5,000 feet above ground level. And this is a stability index chart. So basically the fourth line down there, the one that's highlighted in yellow, if the temperature change within a 4,000 feet altitude change in a layer of the atmosphere is greater than 5.5 degrees Fahrenheit, then referencing back to our S390 courses, even S190, this is considered an absolutely unstable atmosphere. And an unstable atmosphere has been linked to explosive fire growth. Well, in the southeast, having an unstable atmosphere, a very unstable atmosphere, is a very common thing. It's happening today. It happens almost every day in the warm season. So even though this index might be helpful in other parts of the country, especially in the deep south here in South Georgia and Florida, it can be very misleading to a predictor of relating it to fire growth because we're unstable like every day during the warm season. So this particular index can be useful in some parts of the country, but it can have its limitations. The other index, number 2 that we're going to talk about is the Haynes Index, and this is a very popular stability index for portions of the West. So I remember in some of my fire briefings, I mean, all the guys and girls wanted to know, what's our Haynes today? What's our Haynes Index today? And so again, it's a measure of atmospheric stability, and it takes into account the temperature difference as well as the presence of moisture in a layer of the atmosphere above the fire. And the way the Haynes is broken down is broken down to 3 different elevation layers. So if you're in a low part of the country to higher elevations, there's a different way to compute the Haynes given which region you're in. So what this does is it basically tries to correlate the dryness and instability to the worst fire situations. So again, the Haynes, the higher the Haynes, the more correlation there is to higher rates of spread and explosive fire growth. So basically when you start getting to a 5 and 6 on the Haynes scale, then you start to really have your flags go up for, okay, today could be an explosive fire growth a day. So the way the Haynes is calculated is the Haynes Index is a combination of a stability term plus a moisture term. And the stability term, it takes into account the lapse rates of a particular layer of the atmosphere above the fire, and you get a value within that lapse rate layer, whatever it is, whatever layer you decide to extract is the temperature difference within that layer 1 to 3 degrees. And then you use a moisture term, taking into account some layer of the atmosphere above the fire, and it ranges again from 1 to 3. So 3 plus a 3 would equal a 6, which is a very unstable and dry atmosphere. So this has utility out in the West where moisture is more rare at times, but in Florida and much of the Southeast, Louisiana, the Gulf Coast region, this term, Haynes Index term, can always be skewed because we almost always have a moist atmosphere but unstable atmosphere, especially in the warm season. So that's why our Haynes Index doesn't necessarily relate as well to Florida and Gulf Coast region fire growth. Another index, this is number 3 index we're going to talk about, is called the Pascal Stability Index. And this particular index looks at a combination of surface heating or solar radiation plus the wind speed. So if we look at our table here, on the far left, that is the forecast surface wind speed in miles per hour. The middle section of that table is for daytime solar radiation, and at nighttime it considers the amount of cloud cover we have at night. So basically, to extract this Pascal Stability Index, you use your surface wind speed and the amount of solar radiation you're getting at night, or if there's clouds at night or less cloud cover at night, then you extract this letter from this table here. And then you can use this letter to relate to some type of stability term and dispersions. So it's a kind of a quick and dirty stability index reference, but it does have its limitations. The one thing with the Pascal stability index is it's used as a quantifier of vertical dispersion potential, not necessarily horizontal, but vertical growth. So there's that index out there. Now the index that we have been using in Florida for quite a while is the Lavdis dispersion index, and in portions of southeast Georgia as well. And the reason we went towards the Lavdis is not only did this particular index correlate well to large fire growth in Florida, but it's a very comprehensive index. Part of this index is taking into account the vertical distribution of stability through the Pascal stability index. So the Pascal index is input when computing the Lavdis. The Lavdis also considers mixing height and transport winds. So here's two tables. The first one is daytime Lavdis dispersion units and their dispersion qualifier, and then at nighttime those particular numbers are displayed in the bottom table. So as we talked about before, this Pascal stability index uses as input surface winds, and it also considers cloud cover, how much clouds are present to either promote radiation or not. So, and again, that amount of insolation radiation is going to dictate the amount of vertical distribution, vertical mixing that can happen. So let's break down how to extract the Pascal here. All this input for the Pascal stability index comes together to create something called the net radiation index. There's a lot of index words, I know. So the net radiation index, now we're getting into the guts of how the LDSI, the Lavdis dispersion index, is actually computed. So the first thing we need to compute is the net radiation index, and this takes into account cloud cover and the ceiling height to create the net radiation index. So based on what the cloud coverage is and cloud base height is, we come up with a number. There's a table, a complicated, not overly complicated, but a table of how do you extract these particular numbers at the top of this chart based on your cloud coverage and cloud base height. Then you take your forecast wind speed, and where they intersect, where your parameters intersect, you get something called the stability class. Well, the stability class relates to a type of, on the Pascal-Turner stability index, a description of the stability. But what we're focused on to compute the Lavdis is this stability number over here that we get from this particular computation, so 1 through 6. Okay, so say we get one of our stability class terms after we compute, after we look at the cloud coverage, cloud base height, and the winds. So now we have our stability class number. Now we move forward to actually derive the Lavdis dispersion index, and we need the stability class, which we got from the previous slide, and also our forecast mixing height and eventually our transport wind speeds. So in this particular example, this is the graph that we use to extract our Lavdis dispersion index. In our example, we're going to say we have a mixing height of 1,500 meters. This is about 4,900 feet. And so the mixing height is on the bottom of the x-axis here. So at 1,500 feet, we follow it up to our stability class term that we got from the previous slide. And so in our particular example, we're going to say the stability class is a 3. Then we follow the intersection of where these two converge over to the y-axis, and we extract a number, and in this case it's 9. We're going to multiply this, this particular derived number times the transport wind in meters per second. So 9 times 8 is equal to 72 units. That 72 units is our Lavdis dispersion index. So what we use here in the Weather Service, we're obviously not doing all this by hand, but as input to all these different fire weather parameters, the mixing height uses our forecast temperatures, hourly forecast temperatures. It's looking at our hourly forecast winds. From our hourly forecast winds, we derive our transport winds. The stability class is derived looking at our forecast winds as well as our forecast sky coverage and ceiling height. So that is how our dispersions fall out of our forecast. We forecast these particular parameters, run some tools in the background, some computations in the background, and then fall out our dispersion indices. So this is the interface that we saw before, but just to kind of show you again, we forecast the hourly temps, the hourly dew points, the hourly mixing heights, and the transport winds, and then we run a procedure in the background to give us our hourly dispersions. Now, dispersions, all stability indices are to be taken seriously, but also with the caveat that no one index is comprehensive. I mean, you have to look at a whole bunch of different things, different meteorological parameters acting on the wildland fire environment, and stability is just one of those terms. In particular, the Labdus dispersion index is a very sensitive index. And what I want to graphically show you here is that a 2-knot change in our transport wind can have a big difference in the resultant dispersions that fall out of the forecast. So in this particular example, what you're seeing in the yellow circle there, that's centered over some of our counties in Northeast Florida. That's Alachua County. And what you see there, that 2806, that's a forecast transport wind coming at 280 degrees, so from the west-northwest at 6 knots. And then that's Marion County down where Ocala is. So they have a forecast transport wind speed of 280 degrees near 7 knots. And we run our tools in the background with everything else being forecast, the temps, the mixing heights, all that good stuff. The resultant Labdus dispersion is a 29 up in Gainesville, that top number in the yellow circle, down to 39 and 36 across Marion County down where Ocala, Florida is. Now, with all other weather parameters forecasts being the same temperature, same relative humidity forecast, same surface, same winds, a slight change in the transport winds of 2 knots, that's all we did here is add 2 knots, can give us a big difference in dispersions by about 11 to 13 change. So a small change in the transport winds can result in this, big change in the resultant transport, the forecasted LDSI, Labdus Dispersion Index. So, and say this is just in a morning update. So 2 knots to a meteorologist tweaking a wind speed up by 2 knots really isn't significant, to be quite honest. But the way the dispersion, specifically the Labdus dispersion is, it can have a big change on our resultant output. So we have a goal right now in Florida, the Florida Fire Weather offices, National Weather Service offices. We'd like to look at other stability indices, and we are totally open to suggestions. And as I mentioned before, maybe this is a partnership we can work on with the Southern Fire Exchange to try to investigate other stability measures, because this Labdus is so sensitive. It's very frustrating for our customers. The Florida Forest Service, the Georgia Forestry Commission, when they see these fluctuations from morning forecast to the afternoon forecast and from the day before to the next day forecast. They've written burn prescriptions based on afternoon forecasted dispersions, and then the midnight shift comes in and tweaks the forecast by maybe a degree or so, or the transport wind by a couple knots, and it has a huge resultant impact on the forecast dispersion. So this is an initiative that we just collaborated on in February, and again, this is something we'd love to partner with folks on to try to come up with a different index, a stability index for our area. Okay, I'm going to go ahead and toggle through this. This is just a comparison of the indices, and as I said before, the Labdus is what's used here in Florida. And all indices use lapse rate, and again, no one index covers all the bases. So real quick here on decision support services that the Weather Service forecast offices offer. As I said before, we can walk you through some of the hourly forecast data through our internet website, and all of the Weather Service offices are on Facebook and Twitter, so that's another way to receive information. In the Jacksonville area, our briefing number is 800-499-1594 extension 1, but all Weather Service offices are there 24/7, 365 with 2 meteorologists who can give you a weather briefing for the area that you're responding to. So please don't hesitate to call. I mean, we are there to help protect you guys and girls, so please call us anytime. There's the spot forecast interface that we kind of mentioned earlier, and as I said before, we do have an incident meteorologist program. And for large fires, type 1s, type 2 incidents, there's a formal request that's made through NFC, the National Interagency Fire Center, for an on-site incident meteorologist. So there's all the kinds of different support services. I encourage you all to reach out to your local National Weather Service office to learn about other decision support services. The graphics that you see are ones that are issued by the Weather Service here in Jacksonville, but other forecast offices do these. You can see if your office that serves your area has partner emails. You can become part of their database. Learn about when they're having conference calls. A lot of offices have routine conference calls during the fire season, talking about what the weather trends have been and where they're going. So again, I encourage you to reach out to your local office and see what kind of fire support services they offer. So a real quick summary here. We strive to customize our fire weather services and products for our customers. So what I showed you here in Florida isn't necessarily going to be representative of the exact product that they have out west. It's a collaborative effort with our land agency partners, but the general product is going to still be the same, even though the individual elements may vary. Again, I encourage you all to reach out to your local weather service office and establish that relationship. We talked about atmospheric dispersion and how these indices can vary by region. The Labdis Dispersion Index for Florida is a very sensitive index, and we would very much like to investigate alternative indices to use or an index to use across our state. So just keep in mind that we are here 24/7, 365 to support you in your mission and ultimately your safety and your team's safety. So please never hesitate to call for a weather briefing. With that, I'm going to throw it back to David.
Well, thank you, Angie. Once again, if you guys joined us during the presentation, my name is David Godwin, and I'm the Outreach Coordinator for the Southern Fire Exchange. And we just had a great presentation from National Weather Service Lead Forecaster Angie Enyedi. So at this point, we have time. If you guys have questions, go ahead and type them into the chat box on your screen. And I'm going to go ahead and quickly mention two questions I saw that came in during the presentation. One from Joe was asking about whether or not you could get error bars or probabilities associated with fire weather forecasts.
When we talk about probabilities, that is a way the Weather Service is trending. I just got back from a hurricane workshop where they're trending with probabilities in hurricane and tropical storm force winds. At this time, I'm not aware of probability forecasts for like critical fire weather conditions from the Weather Service end. But there might be other experimental products that are being put out by other agencies, but personally at this time I'm not aware of any.
Okay, and I saw another question just came in from Ray on a spot weather forecast. Do you prefer observations from the previous day or the morning of prescribed fires when requesting those spot forecasts?
Well, if the previous day weather is pretty much what you're expecting the next day, if it's a very persistent pattern, like underneath a big subsidence inversion or big high pressure ridge, then I would think the previous day might be good to give them an idea of what the low humidity was and what the winds were doing. But weather is not really going to be carbon copy every single day. So for our users in our area, we like to get a morning observation. We encourage them to try to send in a morning observation. A lot of times that's not overly realistic. I mean, we want to have it closest to the fire site as possible, you know, have them go out there and sling some weather or even use a kestrel and just relay that to us. But a lot of times, you know, folks are submitting their spot request from their office, which can be an hour or more's drive from where they want to burn. So, you know, you do the best you can with what you're given, but ideally the closest to the burn site and the more closer in time to the burn what the weather ob can be taken, the better in our opinion.
So I had a point I just wanted to make sure you were able to clarify. So on those meteograms, yes, when you were able to really dial in to a location through that embedded Esri map, the data that feeds the meteogram are essentially the same data that's going into the spot weather forecast at that 2.5 millimeter or 2.5 kilometer resolution, except
millimeter, that would be awesome.
Yeah, that would be great. The 2.5 kilometer, that's the same data going into a spot forecast minus customization from field measurements. Is that correct?
That is correct. If we
Okay.
don't get any field observations, then you are still going to have a 2.5 kilometer gridded resolution spot forecast. If we can get a field observation to even dial in and refine that spot forecast even more for you, then the better it's going to be.
All the better.
Yes, absolutely. I see a chat in there, or a question about, is there a timeline for the Weather Service to have all of the offices' websites updated? At this time, no, not that I'm aware of. Right now, the fire weather program leaders in all of the offices are polling our users to get a sense of what do they like about the websites, what don't they like. There is a Tiger team that has been established in the Weather Service to work on coming up with a standardized fire weather web page. But in all likelihood, that's probably not going to be available for, I would say, at least a couple of years, because right now we're just in the process of gathering input from our customers. So if you do have a contact with the Weather Service and you want to provide some input, say, hey man, you know, I really like the way we have a link to this particular product, or hey, it'd be really cool if we could put you know, a link to this particular RAWs, a meteogram for this RAWs on our website. I mean, stuff like that, it's great feedback to give your local fire weather program leader at your office. But a target date right now for a standardized Weather Service fire weather webpage has not been set yet. Right now, we're still gathering input.
Did you see that there's one person who's asking about getting on a local to get on that Jack's partner email list?
Wow, that's just awesome. You just send me an email there, Miss Rosie. Angela.Enyedi@NOAA.gov, and we will get that on there, or get you on there.
All right. And you see the question on a turnaround time on a spot forecast.
Here, I need to scroll back up. What's the turnaround time of spot forecast request? Well, usually within 30 minutes is the turnaround time. If it's a wildfire, if it's a burn, let me go back. If it's a prescribed burn, I would say usually within about 30 minutes. But from personal experience this morning, I got 3 requests in all at the same time, so it took me about an hour to get all those requests out because I tend to put a little bit more detail in them. You know, I want to time sea breeze and stuff like that. If it's a wildfire for a spot request, that request, by our directive, is given the same priority as severe weather watches and warnings. So there should be a forecaster responding immediately to a spot request for a wildfire. Let's see here. I see something. Was class day? I don't want to jeopardize the name, Aditya, I don't have any knowledge, to be quite honest, on what the prescribed burn managers look at. I'm not familiar. I do not know the answer to that question. Mr. Ray would like to see a presentation of high split products that NWS produces. I can comment on that, Ray. When you request a high split product from the National Weather Service in the spot interface, you can automatically, for those that don't know, you can automatically be emailed static PDF images of a plume forecast. That's what we talk about high split. We're looking at the fire plume of where, get an idea of where the fire plume trajectory is going to go. And to do that, in the request section of a spot forecast, all you have to do is type the word high split and then a space and then your email. And what that will do is it'll automatically send you static PDF images over a certain time range of when you're burning, and give you an idea of where your forecast plume trajectory is going to go. On the Weather Service end, the only real customization to the high split data that I know of is, instead of sending you static images, we can send you an animated GIF, a loop. So I'm not familiar with anything more refined than that, but again, I'm still learning. I'm still kind of, you know, interacting with everybody, getting a feel for what everybody's doing. So I will, you know, definitely reach out to others and see if there's different products that we can extract from high split. But right now, those are the 2 that I'm aware of: the one that you can get, and then the animated GIF that we can send you. Let's see here.
That's neat. That's new to me.
When is it appropriate to request a spot forecast versus the usual data by county, etc.? That's a very good question from Mr. Norris there. Spots can only be requested by state or federal agencies from the Weather Service. So, you know, Joe Sixpack, who wants to burn a pile of trash in his yard, cannot officially request a spot forecast. We can give Joe Sixpack a verbal briefing by all means. He's one of our customers. But for the spot forecast interface, that can only be a state or federal land management agency. So that's a very good question. All right, let's see here. So Michael said, when we already did that one. But that is where the detail, oh, good point, Mr. Long. That is where the detailed point and click forecasts and the meteograms we showed can be helpful. So very good point there. Instead of, you know, if you're not a federal, associated with a state or federal agency, you can still essentially get similar data from the spot forecast interface through that hourly weather graph. So very good point, Mr. Long. Thank you.
Yeah, as you said, without field measurement input customization, that's the same information that's going to go into the spot forecast.
Got it. That is correct.
All right, I see two folks are talking. I'm going to go ahead and change our format here and bring up our survey. So, well, it looks like, as we see, we've run up to the end of our time, a little bit over. That's okay. So thanks so much, Angie, for joining us and for your great presentation. We do ask that everybody who's still online here to take just a couple of minutes to click on that survey, that Qualtrics.com survey in the middle of the current slide. And there's only about 8 questions, but that'll let us know what you think of the presentation today and give us a little bit of feedback so that we can customize our future webinars to meet your fire science needs. So today's webinar was recorded, as we mentioned earlier, and we will have this recording and presentation posted on our Southern Fire Exchange YouTube channel in about 2 weeks or so. So thanks again, Angie, and thanks everybody in the audience who joined us today, and we hope that this was a valuable program for you. Have a good afternoon.
Thank you all.